Yes, dear children of God, I welcome you back to our second lesson, benzene and its derivatives. And we had stopped on reaction number 3, where we had looked at hydrogenation of benzene to form cyclohexane. And now we've come back to look at the fourth reaction, which is Friedel-Crafts alkylation or Friedel-Crafts alkylation. So Friedel-Crafts alkylation was a reaction proposed by two men. One of them was Friedel, another one was Kraft. So these two people proposed that benzene reacts with an alkyl halide. These are alkyl halides. For all these three examples, these are alkyl halides. So in each case, benzene is reacting with alkyl halide in presence of halogen carriers. Halogen carriers are those substances. It can be a compound of aluminum or iron carrying a halogen. So the halogen carriers we normally use are anhydrous aluminum chloride or anhydrous N3 bromide, and these halogen carriers enhance or they act as catalysts in formation or in alkylating benzene. So also one can use for these Friedel-Crafts catalysts, one can use aluminum chloride as we've seen. One can use aluminum bromide, anhydrous substances. One can use anhydrous N3 chloride. One can as well use anhydrous N3 bromide. All these can be used as catalysts. So it must be, we call them Friedel-Crafts catalysts. And the reaction is called Friedel-Crafts alkylation. Alkylation, it means that you're adding an alkyl group to the benzene. What does it mean, dear children of God? It means that for these alkyl halides that we are having, we shall first be using them. We shall use these alkyl halides we are having to form electrophiles. Then those electrophiles are the ones that will replace the hydrogen in the benzene ring. So I'm going to take you to my next page, and from my next page, I'll begin by carrying out the mechanisms of these substances one by one, but I'll be a bit fast. So what do we do? For this reaction, I want you to first copy this reaction. I want you to copy this reaction, and then we see how we shall handle it. Well, we are having benzene plus CH3, CH2, Br in presence of aluminum chloride. What we do, we shall first react the haloalkane with aluminum chloride to generate a carbonium ion, or to generate what we call an electrophile. So what happens is that we shall have CH3, CH2, Br. We are going to react it with aluminum chloride. Now this will first come here, and this reaction will lead to the formation of, this one has been removed, so this compound left is unstable. So we shall form CH3, CH2 with a plus. Then plus aluminum chloride. This is an intermediate because literally this one does not exist, but this is an intermediate. So this bromine that has come will come with the minus. That's why I'm having it as AlCl3 Br minus. But our main interest is this electrophile. So now, but your first step must be this. Then now you come with your benzene ring. Then with the CH2, rather I can begin with CH2, CH3 with a plus. Now this will come here. I told you before that your arrows must bend once. Don't put love in arrows. When you put love, we put love in making you wrong. So just bend your arrows once, and this will lead to the formation of, we shall attach this alkyl group momentarily on the benzene ring. But remember, where electrons have been removed, we have a positive charge. So we have attached CH2, CH3, but the hydrogen is to be replaced. So this hydrogen will stabilize the ring and you lose it. You must show the loss of that hydrogen and then you form the final compound. CH2, CH3. If the question was complete the equation, then you must have completed it here. You must have completed it by having CH2, CH3. Then the hydrogen lost will react with the bromine to form HBr. So another minor product is HBr. Now, that is the first example. Second example, this was part A. Part B is where we have benzene. Part B is where we have benzene reacting with CH3, CH, CH3, Cl. As I've told you, of course, this is in presence of aluminum chloride. I told you that the first step is first form an electrophile. So first bring this haloalkane, CH3. The mechanism is CH3, CH, bond, Cl, CH3. Bring your aluminum chloride. Now this bond will first break. So we shall first form the carbocation or the carbonium ion. So we shall have CH3, CH with a plus. Where this substituent has left, we shall have a plus. Then CH3. Then of course, plus aluminium chloride, but with a 4 minus. This one does not exist, but because of this minus, it shows you that we are forming an intermediate compound. So this Cl will add on this to become 4, but with a minus. Then now in mechanism, you bring your benzene ring. With the CH3. We shall have CH3, CH with a plus, then CH3. Bend your bond once, coming to attack. You have to bend it once. Don't be like Ngafo, you didn't bend it once. The pen I'm using, but bend your bond once, and you form an intermediate with a positive, and here we shall have CH, then CH3, then another CH3. Of course, with the hydrogen that you're going to replace. So this hydrogen will stabilize the ring, you lose it, and you form a final compound. Final compound will be CH, CH3, CH3. So this is 2-phenylpropane. Yeah? Sorry. Naming, I'm going to assign you to name because in some video, I remember I talked about naming. You can revisit that video. You see how we named aromatic compounds. So from here, let's visit our final example on this. We are going to visit our final example on this work. And the final example here was where benzene reacted with chloropropane. We have benzene. reacting with chloropropane, CH3, CH2, CH2, Cl in presence of iron 3 bromide. What does it mean? First, bring CH3, CH2, CH2, Cl, iron 3 bromide. Yeah. We shall first have this to form CH3, CH2, CH2 plus, then plus aluminium. No. Since here we are having the iron, it will be plus iron, Br3, Cl minus. But you see this one, this is a primary carbonium ion. But ideally, this one being a primary carbonium ion, I need to form a stable one. I can form a secondary carbonium ion. So I'll carry out what we call the hydride shift. I'll carry out the hydride shift. And when we carry out the hydride shift, it means that the plus will shift here to form a secondary, while the hydrogen will shift to this. So we shall have CH3, CH plus, then CH3. And now this is the same as what we had. So this is our carbonium ion. I did this shift so that I create a stable carbonium ion. This is secondary. Why am I calling it secondary carbonium ion? It's because two alkyl groups are attached to the carbon bearing a positive charge. Yeah. So this is a secondary carbonium ion, while this one was a primary because one alkyl group was attached. So we shall have our benzene. Shall have a benzene. Then we shall have CH3, CH3. So this will have and bring our bond there, our arrow here in this substituent. So this will lead to the formation of with a plus here, we shall have a plus, and then we shall have CH, the same thing that we did previously, then CH3, then with hydrogen. So the hydrogen will stabilize the ring and we lose it here. And let's all of us form a product. All of you form for me a product. So this one is what we can say for Friedel-Crafts alkylation. I want you to know that Friedel-Crafts alkylation adds an alkyl group, or the alkyl group substitutes the hydrogen in the benzene ring. Number two, in this part C, we did hydride shift so that we form a more stable secondary carbocation. From here, we shall go to the reaction number 5, which is Friedel-Crafts acylation. Friedel-Crafts acylation is where we are going now. Friedel-Crafts acylation with our reaction number 5. Friedel-Crafts acylation. Now, when we talk about Friedel-Crafts acylation, still we shall be using the Friedel-Crafts catalysts here. We shall be using the Friedel-Crafts catalysts, but here basically, I want you to know that benzene reacts with the acyl chlorides. This reaction involves benzene reacting with acyl chlorides. Acyl chlorides in presence of a halogen carrier. So we shall have halogen carrier or Friedel-Crafts catalysts. So any catalyst can work. But I want you to note that the mixture is always refluxed at 50 degrees Celsius. Yeah, so basically here, we shall have some examples. For example, we shall have benzene. I'll begin with benzene reacting with the an acyl chloride, for example, CH3, CH2, CH3, CH2, CO, Cl. This is called propanyl, 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 propanyl chloride. This is called propanyl chloride, propanyl chloride. If it is CH3COCl, that is ethanyl. So you count the carbons, 1, 2, 3. If there are 3, then it is propanyl. If there are 2, ethanyl. If there are 4, butanyl. So you add an acid chloride in presence of a halogen carrier, maybe aluminum chloride. Okay, so for this reaction, if you are to carry out the mechanism, the first thing to do is still to first create we need to first create an electrophile by reacting with these two, whereby propanyl chloride is going to react with aluminum chloride. So let me first generate an electrophile. And I want you to note that Friedel-Crafts acylation leads to the formation of ketones. So here we basically form aromatic ketones. This reaction is the formation of aromatic ketones. Aromatic ketones. And I want to note for you that ketones have functional group of C. This is a functional group C, double bond O dash. So this is, we shall be forming compounds with the C with an O attached as a must. So how do we get there? First, combine these two to form an electrophile, and we shall have propanyl chloride CH3, CH2 mechanism, then CO. This CO, I can write it as CO, then Cl. So that I bring my aluminum chloride. This aluminum chloride now, I'll have this. It will form, I told you before that whenever you're doing that, let your bonds always reach where they are going. Don't leave bonds hanging in space, rather halos hanging in space. So we shall have CH3, CH2, C, now with a plus, then double bond O. Then plus, of course, aluminum chloride minus. And after this, you bring your benzene ring. Very easy, provided you first generate an electrophile, the rest become the easiest. So we shall have this, then we shall have C. Now I can begin with this one, since it is the one to attach, I can begin with it, CO, then plus, then I say CH2, CH3. Don't begin with the CH3, then CH2. Begin with CH2, then CH3. So this one will come to the carbon, this bond here will, these electrons in this bond will come to the carbon, and as a result, this group will be attached to the ring. So we shall have this, we shall have this, and here you have a plus, then here you have C, and this carbon you have C, double bond O. This is the keto group that I was telling you about. Then CH3, sorry, CH2, CH3 with an H, which H will stabilize the ring, and as a result, on losing the hydrogen, you form a ketone, phenylpropanone. You form your phenylpropanone, and this will be the one. You form your phenylpropanone with C, double bond O, CH2, CH3, CH2, CH3, which is called phenylpropanone. Phenylpropanone. That is it that we found. Then we are going to have some other question. We are going to have some other question. We're going to have some other question related to this, but now I'm going to give you the one with the two rings now, whereby we use benzoyl chloride. Let's use benzoyl chloride and see. If you have to use benzoyl chloride, an example two that I can give you in this case is this, where you have benzene ring, and this benzene ring is reacting with benzoyl chloride, and benzoyl chloride is written as this. You're having benzoyl chloride with COCl, COCl. This is benzoyl chloride in presence of iron 3 bromide. Let's see what will form. Now, still as I've told you, you first form an electrophile. And how do you form an electrophile? For the case of the mechanism, you first have benzyl chloride. First have benzyl chloride. And this benzyl chloride, you're going to react it with the compound that is the catalyst. So you're going to have iron 3 bromide. So you're going to have this. And as a result, you'll be forming and the intermediate. So we shall have this. This is now our intermediate, then plus iron 3 bromide with Cl minus. So in this, you're going to bring your benzene, which is going to attack. So we shall have benzene. Then it is going to attack this. But now for this case, even if I'm going to change the position, I'm going to change the position of everything so that I can attach my C this side. So I'm going to bring C with a plus and a double bond here. So what will happen is this bond will have electrons which will come here, and as a result, you're going to form benzene, be forming benzene with a plus here. Then you'll have your C double bond, or then you have this, you have this, you have that. So you see this, you shall have a bond here, a bond here, a bond here. But remember, here we still have hydrogen, which hydrogen is going to stabilize this. Okay, so in stabilizing this, you are going to lose the hydrogen, and on losing the hydrogen, you're going to form the compound, which I'm going to write down here. You're going to form benzene ring, bond, bond, bond with the C double bond O, then benzene. So this is what will form. And this compound is called diphenyl methanone because there are two phenyl groups with the one carbon, which brings the meth, and with the one group. So it is called diphenyl methanone. Diphenyl methanone. One can call it diphenyl methanone or benzophenone. You can mark it. You can mark benzophenone. And if you are too ancient, you can say diphenyl ketone. Yeah. But that is not very, very, very good. Diphenyl ketone, all these can be names. Diphenyl methanone, benzophenone, or diphenyl ketone. So we shall be good to go. Now from here, allow me go to reaction number 6, which is the reaction of, actually this is my second last reaction. We are going to look at the reaction with alkenes. Still it is alkylation, but where we react directly with the alkenes. This is going to be very, 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 very interesting because you need to know that for all reactions, you must generate an electrophile first. So reaction with alkenes is my reaction number 6. Reaction with alkenes. Reaction with alkenes. So what do we do? What do we do here? Instead of using alkyl halides, because the other time we used alkyl halides to alkylate in presence of halogen carriers, but this time around, still you can alkylate benzene using an alkene and Friedel-Crafts catalyst together with an acid such as maybe hydrochloric acid or phosphoric acid. For example, you can have this reaction. You have benzene. You're adding propene. You're adding propene CH3, CH, double bond, CH2, and conch, phosphoric acid to form what we shall see. So I want to assure you that for all cases, you first generate an electrophile. How do you generate an electrophile here? First have your phosphoric acid, H3PO4, H3PO4, dissociate it. When you dissociate this, you form hydrogen ions and hydrogen phosphate, H2PO4. So now, for me, I'm interested in the hydrogen ion. So I'll get my propene, CH3, CH, double bond, CH2. I'm going to bring my acid, the hydrogen. Remember, double bond is rich in electrons, so it will attack this electrified hydrogen ion, and this will already make it, this will make it an electrophile. Because remember, this will be a plus, and this will be CH3. So we shall have CH3, CH plus, then CH3. Or one can write this one as CH plus, then CH3 times 2. So still that is okay. Now, after you've generated this electrophile using the acid, I told you that they can give you a halogen carrier or an acid, as we shall see other questions, yeah? But in most of the cases, whatever they give you, use that, use whatever they give you. So what we shall do now, after we've generated this, now you bring your benzene. You will realize that it will be the same thing that we did, only that now here, we first generated that electrophile using this method. So after you've generated the electrophile, bring your benzene. I'm going to be fast since we've done it in the previous questions. You have the benzene, so you have CH plus CH3, 2. So you have this bond coming, and as a result, you have benzene ring with the a plus here. Then you have CH, then CH3 times 2 molecules. Then here you have hydrogen. Hydrogen will stabilize this. On stabilizing it, you lose it. After losing hydrogen, you'll be having this compound formed. Very interesting thing. CH, CH3, 2. As simple as this. Now from here, I'm going to give another example which is having some different way of generating an electrophile. So this one, we've just seen that the hydrogen ion of an acid gets electrons and it adds itself within this. So this is addition, basically. This is addition of an electrophile. Okay, so we are going to see what happens if you have something like this. If you have an example where you have like benzene, then you have propene still. I'm using the same propene, but this time around, I'm going to have a halogen carrier, aluminum chloride, and HCl. Let me show you how we generate an electrophile. For this case, you need first to dissociate an acid because the acid will be the first one to attack this. So we shall have mechanism. The mechanism will be, for this case, the mechanism will be HCl, first dissociating to form hydrogen ion and chloride ion. After forming this, then we shall have the propene, that is CH3, CH, double bond, CH2. Then now you bring the hydrogen. You shall have the hydrogen ion. Then you have this. So in this case, we are going to form like what we have before. So you have CH. We had gotten CH in the previous question. We had gotten CH and CH3 times 2. But ask yourself, why? What am I going to do with this Cl? So you bring this Cl. The Cl will come. This Cl, this one very here, it will come on this carbon. That is what all they have given you an acid and a halogen carrier. It means you need to first form an alkyl halide, then now we bring in the halogen carrier. So we shall have CH, I can say CH3, then 2 of them, then you can say CH, then you say Cl. So at this point, now you bring this. So on bringing this, we are going to have CH3, 2, CH, Cl. Now, we are going to also bring our halogen carrier at this point. So we have ammonium chloride. Bring it here, it attacks this. So you'll be forming CH3, 2, CH plus and aluminum chloride intermediate. Now this is my electrophile, which I will use. So the logic is simple. If you're given a halogen carrier and an acid, you must use both. So first use the acid to attach the hydrogen. Then you use the chlorine to create a halocane or to create an alkyl halide. Then this alkyl halide reacted with the halogen carrier the way we use or the way we've been doing in other examples. So this halogen, after creating this electrophile, let every viewer's role to complete the mechanism, or viewer's task to complete the mechanism. So everyone viewing, complete this mechanism after you've gotten the electrophile. Finally, still this is for the viewer. After I've given you an electrophile, this will be for the viewer. Now, every viewer following, we are going to have benzene. We're going to have benzene. And I'm going to add ethene, H2C, double bond, CH2, HCl here. So each viewer, I thought, okay, let me give you the electrophile and then each viewer will complete. So for the case of mechanism, first have HCl split from H, hydrogen ion and chloride ion. Now, because I'm not given a halogen carrier, I just need to form I need to form an electrophile immediately. So I will have H2C, double bond CH2. I'm going to bring in the hydrogen ion. So you'll have this. And as a result, you're going to have CH2 plus CH3. So with this electrophile, I want everyone to complete that mechanism. This brings me to the final reaction called halogenation. a final reaction called halogenation. So for the case of halogenation, we are adding halogens, or halogens are substituting hydrogen in the benzene ring. I'm completing with this halogenation, 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 halogenation. Now, this is my final reaction. For the case of halogenation, dear children of God, for the case of halogenation, we are going to find out that we shall be adding a halogen, either chlorine or bromine, in presence of a halogen carrier. Or sometimes we don't give it the halogen carrier, we want you to generate the halogen carrier by yourself. You're going to look at all those cases, but to begin with, let's begin with a case when you're given the halogen carrier. How do we go about it? For example, you're given benzene. Even if they give you it, even if they give it to you like this, and they say plus chlorine in presence of ammonium chloride, just to know here you will automatically form chlorobenzene. But when it comes to mechanism, though we've been doing, when it comes to mechanism now, this is somehow different from what we've been doing, because for the case of mechanism here, you'll first have chlorine, 2 atoms, Cl, then you have aluminum chloride. So you're going to have this. So this will form for you chlorine and aluminum chloride intermediate 4. This one is partially positive. For this case, this is partially positive, and this will be partially negative. You must present it this way. The generation of an electrophile. Now, for this case, we shall use these two all together. You're going to use these two all together. So what we shall do, you are going to get benzene. You're going to get benzene. You're going to get benzene. Then now you bring this mixture. You're going to have Cl and aluminum chloride, partially negative. So at this rate now, you're going to have this and this going. Okay. So in this case, still without wasting time, you're going to attach your Cl momentarily with a hydrogen. So you have this with a plus here. Then here you have Cl. Then here you have the hydrogen. The hydrogen locks, stabilizes the ring. You lose it. You form chlorobenzene. Since we're interested in the main product, we shall not ask you where this one has room. For you, write and stop on this. So that is how we form chlorobenzene. B, reaction B, related to this, reaction B. For the case of the reaction, based on this previous example, I want you to first see that you do this when the halogen is given and the halogen carrier is given. But sometimes we deny you the halogen carrier. For example, in this reaction, which we are going to do. In the reaction we are going to do, I want you to see that in this such a question, we can give you benzene. We give you benzene. For example, this. And we say bromine and iron, just this. Bromine and iron. I can say heat. For you, you know that you form bromobenzene. But we want to see how we form bromobenzene. Okay, so we want to see how this one proceeds. Okay, we want to see how this one proceeds. So for this case, we are going to see that if you're given a halogen and a metal which causes a halogen carrier, it can be even aluminium, you first generate the halogen carrier by yourself. That is the trick behind this. So you will need to first get iron, you react it with bromine, so that you generate the halogen carrier by yourself. Okay, so in this case, you're going to have, in your first step here, if you're given such, your first step should be getting bromine plus iron. You first form iron 3 bromide. First form iron 3 bromide. So in this case, we are going to have bromine and iron reacting. So we shall have iron plus bromine. Okay. First form iron and bromine. These two will form what we call iron 3 bromide, and this equation must be balanced for it to get a mark. So shall form iron 3 bromide. Since it is an inorganic equation, it must be balanced. And you balance it by putting a 2 here, by putting a 3 here, by putting a 2 here, making it 232. So if you've balanced this equation very well, now you've generated the halogen by yourself. After forming the halogen by yourself, now you bring Br with the halogen carrier, iron 3 bromide. So this one will be, you have this, and this will form Br dash Fe Br for partially positive, partially negative. So this is what we need for our mechanism to proceed. So I will have benzene ring with Br Fe Br4 partially positive, partially negative. I will get here, and this will be here. So this will form as this will form for us the bromine group will be attached, but of course here we shall have a plus, and then here we shall have Br, and here we shall have an H momentarily supports. So here, after this one stabilizing the ring, you just lose the hydrogen, and on losing the hydrogen ion, you form your bromobenzene. So for every viewer watching me, I want you to do this on your own. I want you to carry out this reaction on your own. This one here, get benzene, reacting it with chlorine and iron 3 bromide, hit, complete, and work out the mechanism. Complete and work out the mechanism. Now, before I end this session before I end this session of reactions, before I end this session, I want you to note the following. I want you to note that the product of chlorination, when you have added chlorine, The product of chlorination is chlorobenzene. When you have added chlorine, you form chlorobenzene. While the product of bromination, when you have added bromine, is bromobenzene. Now, these the bromination test is used to distinguish between benzene and cyclohexane. That is in organic analysis. Yeah, bromination. I want you to note that bromination is used to distinguish. Bromination is used to distinguish between benzene and cyclohexane. You need to note this. Bromination is used to distinguish between benzene and cyclohexane. So they can ask you the reagent that is used to distinguish between benzene and cyclohexane. So the reagent that distinguishes the two, you should always write it as bromine in presence of bromine, in presence of anhydrous aluminium bromide. Anhydrous aluminium bromide. And the observations would be, for the case of benzene, we always see a reddish brown solution turning colorless. Reddish brown solution turns colorless. While for the case of cyclohexane, no observable change. And we have looked at halogenation with the chlorine and bromine, not iodine, implying that iodine does not easily substitute benzene in the same way. Okay? If you want to use iodine, to carry out halogenation using iodine, you do not use those, you do not use these compounds that we've been talking about. Yeah, you do not use these compounds of the Friedel-Crafts catalysts. Okay, I want you to note that if you are to halogenate, or if you are to carry out halogenation using iodine, it is done by refluxing benzene, iodine, and conc nitric acid. So the substitution of iodine is not carried out in the same way like how we got this, but it is instead done by, when you have benzene, for it you must be having benzene. Now with benzene, you add iodine and conc nitric acid, then you reflux. Now when you reflux here, that is when you get iodobenzene. So don't be like, can't I have benzene? This reaction is wrong, the one I'm writing. Don't be like, can't I have benzene? And I say iodine in presence of aluminum chloride. God may not forgive us if we write this, because this is not true. This is wrong. Halogenation using iodine is not done the same way as halogenation using chlorine and bromine. If you want to use iodine, you must use conc nitric acid and reflux. Now, for the case of today's work, for the case of today's work, we've looked at different reactions. But then, before I go still, I want to remind you of one thing, because I don't want you to meet it somewhere and be like it was not talked about. I want you to know that halogenation of benzene using chlorine, if you use chlorine directly with UV light, if you use chlorine in UV light at room temperature, when you use this direct, you do not get, when you use this, you do not get the same product as the other. You do not get chlorobenzene here. Instead, you get 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. Okay, so for this case, if you use UV light, you do not get chlorobenzene, but you would rather get Cl, Cl, of course with H, wherever there is Cl, there is HCl, Cl, Cl. Wherever there is Cl, there is H. So you just have called 1, 2, 3, 4, 5. Don't give up when writing this thing. 6. Because there are 6, you will say hexachloro. Hexachlorocyclohexane. Even if we use bromine in presence of UV light at room temperature, you'll form 1, 2, 3, 4, 5, 6 hexabromocyclohexane. For that case, it will be hexabromocyclohexane. By the way, these 1, 2, 3, 4, 5, 6s, both for hexacyclo or hexabromo, are normally used in making insecticides. Those ones who will do which course deals with these, I have forgotten, but you will meet such things in biometallic and organometallic chemistry at higher levels of learning. So allow me end here for today and wish you the best. My next recording, or my next lesson 3, I'll be showing you the uses of benzene, or how we use benzene to carry out synthesis. Then from there, we shall go to methyl benzene. I wish you all the best. Mighty God bless you.